There are many kinds of batteries in the world, from small AAA batteries we use every day to large car batteries. But how does a battery work? The electricity created by a battery is caused by a transfer of electrons, or a redox reaction. A battery consists of a cathode, an anode, and at least one solution as an electrolyte. The cathode and the anode don't physically touch, but are connected through the electrolyte. The redox reaction happens between the ions in the electrolyte and either the cathode or the anode. Cations are attracted to and reduced at the cathode, and anions are attracted to and oxidized at the anode.
Batteries provide power for many electrical appliances. Imagine a world without batteries. Things like your phone, laptop, car, flashlights, calculators, and clocks won't be able to run independently. Our world is filled with batteries, but what happens when these batteries are used up and need to be thrown away? Many batteries used today contain dangerous chemicals or heavy metals, all of which can damage the environment if not disposed of properly. So in our lab, we tried to find a way to make batteries that wouldn't harm the environment.
The first day of our lab was really hectic and rushed. As you can see, our work area was cluttered. We had a voltmeter, aluminum foil, copper wire, film canisters, sandpaper, an assortment of tools, a variety of electrolytes, and a glue gun. First, using a sharp object, 2 holes were made in the film canister, one on the bottom and one on the side. Next, a piece of aluminum foil was cut out and placed along the inside wall of the film canister. Then a section of copper wire was sanded and put in the hole on the bottom of the canister. The glue gun was used to seal off all the holes and make the canister watertight. At least it was supposed to. After our first day, we had made 2 batteries, both of which leaked when we added water.
This forced us to bring in a pre-made container on the second day to perform the reactions. We decided to change the type of electrolyte in the battery as our variable. We used distilled water, orange juice, 3 different concentrations of sodium chloride solution, and vinegar. We first used distilled water as our control test. As you can see, distilled water generated 0 volts of electricity.
For our first test, we used a solution of 2 grams of sodium chloride for every 50 milliliters of water. This solution generated 0.3 volts of electricity. In our second test, we used a solution of 4 grams of sodium chloride for every 50 milliliters of water. This solution generated 0.35 volts of electricity. Our third test was done with a solution of 6 grams of sodium chloride for every 50 milliliters of water. This solution generated 0.4 volts of electricity, giving us a linear progression of the voltage produced to the concentration of sodium chloride in the solution.
We used vinegar for our fourth test. Vinegar generated the most voltage out of all of our electrolytes, giving us 0.6 volts of electricity. Our fifth and last test was done with orange juice. Orange juice ended up generating 0.2 volts of electricity, the least of all of our tests. And that concludes our lab.